This is Algebra 1, Term 5, Lesson 12, Dimensional Analysis. We'll begin with a Desmos activity, and then we'll do a fun card activity from Math Equals Love called Shape Conversions, and we'll finish up with some GeoGebra practice. So let's get started with Desmos. So this activity should take the bulk of your time. There are a total of 16 screens, and we'll begin with something fun. Students will decide whether it's better to walk across 25 feet of Legos with bare feet or walk across 3 meters of hot coals with bare feet. So they will discuss that. The whole purpose of this part is just to get them thinking about these links and what they are and what they represent. On screen 2, they will click this button to start, and then they will move this ruler and measure this pencil. There are no units, and that was intentional on this ruler because that's part of this task, is to determine what unit makes sense. So on the next screen, they will talk about that, and then they will put that here. Good point, good time to start discussing what units of measure are and what they are good for. Like, we're going to measure distance between my house and your house. We might use miles, but if we're going to measure the distance between our desks and the classroom, we're probably not going to use miles. If we're measuring a pencil, we're probably not going to use meters. What could we use instead? So maybe throw some of these up and talk about them. It is surprising that kids make it to high school without knowing some of these basic units of measure, but it happens. In fact, I'd say a large number of my students were unfamiliar with the size of a centimeter or the length of a yard or something like that. This next one was very interesting because I'm not sure what unit of measure they're using, because it's not customary to use a unit of measure for a building and only get 8 or so. It looks like it's about 8 or 8 with a decimal. And so the question is, what are the units? Feet are too small. No building is 8 feet tall, and it looks like there's at least 10, maybe 12 stories to this building. Yards is too small. Miles is too big. So it's got to be something in between. What I did is I actually looked up some of the metric system measurements in between a meter and a kilometer, and one of those makes sense. So you may talk about the metric system and units of measure, but this is a great conversation starter, and that's kind of a good time for you to stop again and talk about different units of measure, throw them up, talk about them, and let them decide what unit of measure makes sense in this context. Now, when they get back to this slide, it's actually taken a picture of what they've done. So if they have their unit of measure here, you'll see on the next screen, it's got a copy of that graph, and now they can draw on it. All right, here they're doing this again. We're choosing appropriate units. So the first half of this assignment is all about the most basic understanding of measurements, and these are all linear measurements. So 1 foot, 1 meter, 1 yard, 1 kilometer, 1 mile. This is self-checking. It doesn't say it, but when they're all correct, a message will appear at the top of the screen to tell them that it is correct. So you won't have to put your dashboard up. It does tell them if they got it. And so we're now into an application of unit conversion, and it's using an unconventional means of finding these conversions using proportional reasoning, which I really like. A lot of times kids are just mindlessly calculating using a multiplication or division and a unit conversion factor, but they're not making sense of it, and that's why they go, they'll multiply when they should divide and vice versa. So this is a fantastic approach. So here a person got a ticket for driving 75 in a maximum 80 zone, and she's insisting she did not speed, but what could have happened so that she actually did speed? So let the kids talk about that, and then they're going to choose an answer and talk about the fact that the units are not in miles per hour. That's what we're accustomed to in America, but not every country uses that system of measurement. And then here they're going to use a table to actually figure out her system of a measurement. You'll notice that the distances in the table are not equally spaced, so they cannot just count up. They have to, and I actually did that. I mean, I will be honest, as a teacher, I didn't even notice it right off, and then I was like, wait a minute, they're jumping around here. So really good time to stop, pause, think, reflect. So they're using proportional reasoning to figure out what it must be, these distances. They should not have to do a ton of calculations to find this. They should be able to use ratios, proportions, and the numbers that are in the table to generate these answers. And the more they can think about it and do that, the better. All right, now we have veterinary weights. These are in kilograms, so obviously in America we're not as familiar with kilograms. We're much more familiar with pounds, but they do need to be able to measure or convert back and forth. So they've given you the unit. 22 pounds is equivalent to 10 kilograms approximately. So using that information, can you figure out what Fido, Spot, and Bella weigh? These are pets. They should be able to do these calculations by using proportional reasoning, and that's what we're kind of aiming for here. When they put those values into that table, they will show up on the number line. They'll be added to the weight number line on the top, so they will see those in their graph. Here we have another screen about weights and veterinary weights. A certain medication can only be given to animals over 25 kilograms. How much is this? Show how to use a table to figure it out. So using proportional reasoning, what could we do to get to 25? They can add 2 more rows, and I think they can even increase the number of rows here. I believe they'll be able to do that if they need to figure it out. And there's more than one way to do it. So this is a great opportunity for teams to work together, come up with some strategies, and share that out. All right, this is a very basic unit conversion. In all of the ones, these next few screens, they're basically just converting time units. So minutes, seconds, hours, and so forth. So in this case, we have beats per second. How many beats is that per minute? Here we have kilometers in minutes. We want to know what kilometers per hour the speed is. Here we have a boy walking 400 meters in 5 minutes. Well, what is his rate in meters per second? So here we have our velocity graph that we've used in the past. Notice the units here on the right are time in hours, and the speed, which is also the velocity, is miles per hour. So when you multiply hours by miles per hour, the hours divide out. They are being asked to explain how the units work in this problem. If your students are struggling with this part and don't know, it might be smart to go ahead and pause this and go ahead and do your slides activity, your shape conversion cards, to get that in their minds, and then you can come back and complete the rest of your Desmos activity. So consider breaking your Desmos activity into 2 parts if you think your kids need that. And then this is it's a really good rich task. It does have multiple layers to it. So as soon as they do type an answer in, they're going to be asked to explain what they're doing. So they should submit some kind of work along with their answer. So the question is, will the truck fit under the bridge? Yes or no? And then how much room is there between the top of the truck and the bridge? They're going to have to do some calculations here. We're told in the picture and in the text of the problem that the height of the bridge is 11 feet 8 inches, and we are also told here that the truck is 3.5 meters high. So we'll need to do some conversions. The teacher moves and the sample responses, be sure to check those. They give more than one option here, so you will have to manually look at these answers to see how they're doing. There's not one right answer, because they could convert from inches and feet into meters, or meters into inches and feet. In either way, you can answer the question. When we get to slides, we're going to work on a math equals love task, and they're going to convert from one shape to another using dimensional analysis. So I want to first go to her site to show you where this came from. This is math equals love, and this is the dimensional analysis shape cards activity. I called it shape conversion, and so here you have kids working with these cards. She did color code her cards, and I do recommend that you do that. So when I show you the cards in a moment, I'll explain how to run these off. If you'll use colored paper for the shapes that the cards that only have one shape, and if you'll use a different color paper for the ones with the ratios, that would be good. It looks like she did this with individuals, but you could do these in pairs. I kind of recommend that. Teams of 4 might be too much, so maybe pairs would be better for this one. And then as they do the conversion, you see it here. This is this is the picture I put on your slide. And here's some more work, so they're showing you that. Now, unfortunately, on this site, I went to the original place where she got this, which is here. And you can read a blog post about this activity and some text about it. Here's the thing. Here's your image. But this image is really small. And then when I went to the site down at the bottom to download it, I do not have access to download it. So I thought, well, I'm just going to recreate it. So I did that for you. And I created a Google Doc, which will be linked to this assignment for anyone to use that wants. And so here it is. So here are the cards that they'll cut out. And this one I would do in a different color. So in the one in the picture I showed you a moment ago, these were orange in that picture. So maybe use colored paper for this page, and then you could use white for this page. But they're going to take these and place them so that these shapes basically are dividing out. So this is like a hexagon divided by a hexagon, which is like 1. And so that's dividing out, and then this diamond divided by this diamond is 1. And so that all that's left here is this star. And so they're going to describe that over here in their own words as best they can, but they're basically dividing out the image or the shape that they're given to end up with the only image that remains in the numerator will be their answer. The key is to remember this is like a numerator. When they see one shape, it's like over 1. So this needs to be on the top, just like that one. Now the next screen, same thing. They're going to show me how to convert. So they will take their own cards, cut them out, lay them down, take a picture of it with their device, and insert on this slide. They will do it again from a circle to a hexagon. They will do it again from a square to a hexagon, then from a diamond to a circle, and then a circle to I think that's a decagon. Now the GeoGebra practice, I have it for last, but you could do this before heading back over to your Desmos activity if you think they need it. But what they're going to do here is click on the link, and it's going to take them to task 1, and they're going to drag these 2 purple rectangles into these 2 spaces. Now the goal here, it says how many kilometers. So I want to end up with kilometers. I do not want miles. I want to know how many kilometers. So the final result should end up with kilometers. So since they've just done that shape activity, they should know which one they're trying to divide out and where it goes, and the one they don't want to divide out and where that goes. They do get 2 checks, so obviously if they miss it the first time, they'll switch it and fix it. But hopefully they'll get it right, because they want this number to say 5, and I don't think they get credit if they miss it the first try. So they need to get it right the first time to get this number correct to go up. As soon as this number reaches 5, they will take a picture of their screen, and they will place the picture on this slide. And that concludes our dimensional analysis lesson. Y'all have a great day.